So your comparative advantage is going to determine who produces what when they work together. So that's a very important concept. So next up, I want to kind of think about their combined production possibilities frontier. So we just talked about their production pattern when they work together. Now I kind of want to more show it graphically, the same way that we showed their individual production possibilities frontiers, these guys here. I want to draw their combined production possibilities frontier, okay? So if they're combining, we've already looked at their max and their min number of cars and songs, right? But it's not just enough to add these guys together and say 2 and, oh, sorry, that should be a 2, and then, 4 and 42 plus 24, it's not enough on that. And the reason it's not enough is because we just defined comparative advantage, and we said that, it doesn't make sense for them to split it up half and half, where one person makes half the songs, one person makes half the cars. And it doesn't make sense. It makes sense for them to split it such that the person with absolute advantage makes the good, right? Those are not the right ways to think about this. We want to think about the person who has the lower opportunity cost should do the thing that they have the lower opportunity cost in until they can't, right? So basically, we're going to have this point where there's complete specialization. So at some point, we're going to have the Marshall-Kendrick combined allocation of 49.7, okay? And if they want to make additional cars above 49, what we can do is we can take away some of the songs Kendrick makes. So let's say Kendrick makes 6 songs, and they want to make additional cars on top of that. So they want to make they can make 53 cars, 6 songs, right? If Kendrick takes away one of his cars, or sorry, one of his songs makes a car, right? If they wanted more than 49 cars, they could do that. It's just that Kendrick would then have to give up some songs, and they could make 57 cars and 5 songs, or 61 cars and 4 songs. So basically, I'm just adding 4 cars a day, okay? And 65 cars and 3 songs, and 69 cars, 2 songs. Not Soggins. 73 cars, 1 song, and 77 cars, 0 songs, right? And this should look familiar because this was the max number of cars that they could make, and we had already established that, right? 77 cars, 0 songs. That's if they spent all their time making both. Okay. So in this example, the person with comparative advantage in songs is still spending is still making all of the songs. It's just, and the person with comparative advantage in cars is still spending all of their time making cars. It's just that they want to do more than 49.7 cars. They want 53 cars and 6 songs. So basically, imagine an economy in which the rate of prices, the price for a car is a lot higher, such that you would want to make more cars than songs. And then if if the price is right, you want to make only cars and 0 songs, right? That's still an efficient outcome because you're still assigning the person with the lower opportunity costs to do the thing that they have a lower opportunity cost of doing. It's just that the economy values cars more than songs. So it might be the case that they're both doing their opportunity costs, their comparative advantage thing, but someone else has to chip in and suffer some of the opportunity cost. Okay, so basically, like, let's say we're an economy that needs exactly 61 cars, then it needs it must be the case that Kendrick should be making some cars, even if he has comparative advantage in songs. And it's not a violation of the production pattern. It's not a violation of efficiency to say that Kendrick should make some cars, as long as he's making all the songs, right? So these are all points on the combined PPF, but that's only half of the story, right? Because we could take away some cars and give it to make Marshall do some songs. So we can, if, for example, if they had a deadline where they needed to make 10 songs, and then the rest of the time they could spend making cars, right? So if they need to make 10 songs, it should still be the case that Kendrick should make all the songs until Kendrick maxes out his time, and then Marshall should chip in and make some of the songs as well, okay? So if Marshall chips in, okay, and they want to make 10 songs, for example, so I'm just going to do that over here and say, let's do, so this will be 8, 9, 10. So 10 songs, right? If they're making 10 songs and Kendrick has comparative advantage in songs, Kendrick should make the first 7. Then Marshall should make the next 3. If Marshall's spending 3 days, so I'm just going to write it out. Marshall spends 3 days making songs. Kendrick spends 7 days making songs, right? If that's the case, so Kendrick's going to make 7 songs. Marshall's going to make 3 songs. Marshall makes 3 songs. Kendrick 7 songs, right? How many days does Marshall have left to make cars? Marshall has 7 minus 3 days for cars, right? So that's 4. 4 days for cars. Okay, Kendrick has 0 days for cars. So if Marshall has 4 days for cars, Marshall has 4 days for cars times 7 cars per day. He can make 28 cars. Okay. So if they must make 10 songs, then Kendrick's going to make the first 7. So you know that Marshall must spend 3 days must make 3 songs, right? If Marshall makes 3 songs and he makes 1 song a day, he must spend 3 days making songs. So that leaves him 4 days for cars because he has 7 days total. And if he has 4 days for cars and makes 7 cars per day, he has 28 cars. Okay. So together they can make 28 cars. Okay. So I'm going to ask you, if they have to make 12 songs, how many cars can they make as a group? How many cars can they make? Okay. I'm going to stop it here. I ask you to do this at home, and then we'll go through the steps.